And what we are going to talk and discuss tonight is a very hot topic, actually. And I very much would like to appreciate all persons who took the challenge to be sitting in front. Welcome. It's fine, don't worry. Why? Because actually none of us is very deep specialist in the topic, because it appeared quite recently. But you know, my philosophy is, if you would like to be the professor, which is from Latin, you should know a little bit about everything. So, and if you don't know, you should find the sources and make some statements. So, welcome to the panelists, Professor Mario Costa, Professor Slaven Dobrovic, Ifi Foley, Dr. Ting Ma, and Professor Daniel Rolf Schneider. Thank you very much. And let me a couple of slides as an introduction. And by purpose, we, with Ivan Fan, selected some slides which are a little bit controversial. The first one is the problem of plastics appeared quite recently. But as you can see from this slide, it's not recent. It was already commented about 50 years ago, and some plastics, or better if you are chemist, polymers, have been used a long time ago. And some of them, like microplastics, which are now discussed very much, appeared with the beginning of tires, because a lot of microplastics is coming from tires. And plastic waste generation per person. This is an interesting table. The bad guys, or bad countries. Okay, the first two, Kuwait and Guyana, are small countries. But the third worst is Germany. Surprise, surprise. Fourth is Netherlands and Ireland. And after United States. Well, it's nothing wrong. It depends also on the number of people of the population. And another slide is share of plastic waste that is inadequately disposed. And we've got countries which are doing well. We've got countries which are not doing very well. But it's one problem with this slide. It deals only with macroplastic, not micro. Because micro, how to recycle microplastics? They are just going to the seas. And this is what I mentioned. Microplastics are considered plastics which have got less than 0.2 inches in diameter. And surprise, surprise, they come from fibers, from pellet, from cosmetics, microbeads, capsules, tires. And also, so when we clean our teeth in the morning, we are releasing a lot of microplastics. When we are making tea from the tea bag, which is from plastics, there are several millions of them. And there are sources which we wouldn't consider as sources of microplastics. But, well, we have to consider it. Impacts. Now, this is quite a question, because we collected a number of statements, and so far it's not a strong statement from health authorities. We look for the US, we look for the Germany, for the UK. it's no strong statement that plastics are deadly dangerous for people. They are dangerous for birds. They are dangerous for sea organisms, which are taking them as a substitute of the food. But for humans, some sources are considered microplastic something as a fibers, which are coming through our digestion and not to do too big harm. Well, very much discussed is how to drink. Because of McDonald's, they decided to be politically correct, to move from plastics to paper. And they found that they are degradable, but they are coffee degradable. Usually when you drink the coffee, at the half it's already melting. And why we are showing it is we can think we can make it from wheat, we can make it from steel, we can make it from paper, glass, but why we need it at all? Can't we drink coffee just without a straw? So sometimes it's not a question of material, but sometimes it's the question of attitude. And now plastics versus paper cup. We took several sources, but consider Royal Society of Chemistry, UK, as a quite credible source. And look when we compare plastics versus paper cup. Well, we need for paper 33 grams of wood. Paper cup uses 28% more oil, needs 36 times more chemicals, consumes 580 times more wastewater, produces 10 to 100 times more pollutant, residual waste, and 3 times more emissions. When we incinerate, paper provides about 20 megajoules per kilo, but if it's plastic cup from polystyrene, it produces more. So waterproof plastic layer on paper cups, because it can't be just paper, it makes it not recyclable. It can be only incinerated. So plastic is cheaper, lighter, but at the moment everybody is saying we are more environmentally friendly, we don't use plastic cups at all. So I'm not saying it's bad and wrong, it's up to you to discuss, but it's not everything as simple. And impact of different materials. We've got here bugs. High density polyethylene paper, low density. It depends what we would like to go for. Energy, water, material, greenhouse gases. Actually, if we move from plastic cups to paper, we will generate much more greenhouse gases. So, is it right or not? Important is also if we are using the cup once or several times. I've seen the conferences which were really sustainable, where everybody received at the beginning cup and used it for the coffee and drink through the conference. Not bad idea. Just it is about management and organization. So this is for the introduction. A few things, few thoughts, and I will now ask our panelists. And we haven't got a strict order, so who would like to start first? Yeah, Daniel.
Dear ladies and gentlemen, so here I am again, but now I will be I will try to give some contribution to today's discussion. So I will try to cover as many topics as possible in a short time. So it will be a bit hectic, but we'll discuss it. So you are probably aware that overall plastic production in the world is growing steadily. So we are now have huge amounts of plastics. For example, in 2017, it was 348 million tons of produced plastics globally. Today, I think last year it was like 359, so it is like 4% of the rate. In Europe, if we talk about Europe, it's 65 million goes in that year. The biggest, for example, demand for plastics comes from packaging industry. It's 40% at least in Europe. And the problem with that is that like 80% of that packaging waste, packaging becomes waste. So Europe, as many of you know, decided to change these things and actually promotes very much the recycling, recovery, avoidance, etc. And actually, a couple of years ago, for the first time, we had more plastic recycled than it was landfilled, which the numbers like 31% for recycling and 27% for landfilling. The problem is that the rest was actually energy recovered by incineration. I have to mention European Union goals. EU is the forerunner in the waste management often. So from the current recycling rate target for general municipal waste of 50% recycling by till next year, actually 2020. So from 50, we moved to 65% in the year 2035. In packaging waste, of which plastic is nearly half, we move even more, so to 70% demand for recycling in 2030, of which 55% is for plastic waste. So these rates, these targets are huge. And many countries will have problem to fulfill it if you don't have an efficient and comprehensive system of collection, recovery, and recycling, especially considering packaging waste. Recent ban of China several years ago and other Asian countries are following of forbidding import of different categories of waste, including recyclable plastic, of course, with a certain level of contamination, left EU and many other countries like United States, Australia, Canada, etc., with a lack of local capacity for recycling, or economic reasons, actually. So, for example, EU exported 50% of its separately collected material for recycling was exported, 80% of which to China. This is considering to plastic waste. And now we have a problem. So, according to European legislation, you should avoid the waste as much as possible. We are witnessing a certain change in legislation, banning one-way plastics or plastic cutlery, banning the lightweight bags. So this is the good direction, but it's only very small percentage, as Irji said. Also, when you consider the separate collection system, like yellow bins, yellow containers, you can often find different types of waste which does not belong actually to that containers, like electronic waste, organic, textile, whatever, bulky, and that presents very much of the problem for later recovery and recycling. For example, if you consider, we have data for one of the neighboring country of Croatia from the real facilities in material recovery facility for the waste which is separately collected, that includes not only plastic but also other categories. From the all collected waste, the recyclable material is 20 to 35%. Because different reasons, pollution, contamination, complex material, etc. From the mixed municipal waste, the recyclable material is even less than 10%. So, where the rest is going? If you want to fulfill new European legislation which will prevent landfilling of separately collected waste or completely decrease the landfilling below 10%, you have no other options currently than to energy recovered. And again, this is by incineration, which is not the best way. Also, as I said, in reality, these material recovery facilities have problems. This is first, like in yellow containers, you have contamination with organics, oils, detergent, whatever. Then the complexity of material. You have different elements, material, fillers, colors, retardants for firing. Then you have multi-layer materials. And this is very difficult sometimes to recycle, even not only mechanically, but also chemically. And we are now at a certain point of the state-of-the-art limit of the current technologies. Data from another country in the region shows that the theoretical efficiency, or real efficiency of the material recovery plant is only 30 to 40% of the theoretical one due to these reasons. So, the future is not so bleak. I mean, there are some research going on, for example, especially in digitalization of waste management, robotics, sensorics, I don't know, especially tracking of input and output material streams and quality, so online on-time characterization, self-optimizing machines. All this will be made in the future waste recovery facilities according to Industry 4.0 principles. Of course, there are some questions about the recyclability. What about the mineral residue or ash in SRF, solid recovered fuel? Can be considered as recycling or not if it is included in the clinker material during cement production? So currently, EU legislation doesn't recognize it. I just put some of the slides of the already operating intelligent robotics sorting machines in Europe. So there are several producers which use robotics. It's not a solution for everything. I mean, for example, there will be probably certain categories of waste, like construction and demolition waste, where these machines has more sense than in others. But they're already capable of separate different polymer fractions, polymer types, and that is going very fast, like 4,000 picks per hour and arm. Of course, there is a problem, different problems. I have video here, but I don't have time to show you. You can click it later on a YouTube link here and look at how it is going. But it is really working. The problem with all this digitalization and Industry 4.0 principles is that you basically have very low-cost material, almost zero, garbage, and you implement multi-million euros machines. So there are dozens of sensors, even now robotics. I haven't mentioned collection, automatization of collection, tracking of vehicles, containers, etc. So, but that will probably change because the requirements of the industry in Europe and elsewhere are now that they require more quality material, recycled material. And often this is followed by legislation, certain legislation according to environmental protection. Just to mention some of the collection schemes like extended producer responsibility initiatives, which could also help to increase the input of collected material. So one of the quite successful and recently even recognized by European Union is deposit refund schemes, which can collect, for example, 90%, even more of single-use plastics. In Norway, it's 95, 97. But the main issue of such schemes is that you get the almost clean monofractional material, which is 99% recycled and often in the closed loop recycling process, like bottle to bottle. You have here that difference between the green containers, yellow containers, green dot schemes, and the deposit ones. So in deposit system, you can have, as you see, this is an example for the German PET juice bottle. So 99% of recycling, while in the green dot system, they have just a moment, 25 to 31% of recycling. 1% goes to energy recovery, and the rest is not simply not collected. So, and for the end, I just have to mention also energy conversion technologies apart from incineration. I've got recently the new project on the advanced technology like pyrolysis and gasification of plastics. So they're quite promising. I won't go too much in deep here because the other speakers will talk more. But the idea is to valorize plastic waste into some other products, not only energy, but also fuel, chemicals, and new polymers, for example, the material for new polymers. Also, here goes the chemical recycling, like from depolymerization, cracking, reforming, hydrogenation, etc. Again, EU legislation doesn't recognize that as a recycling. Not only chemical recycling, but also not pyrolysis and gasification. So these are some things to ponder. And if you wonder if that is commercially available, yes, some of these are already working. So you can see here just two examples. One is gasification of plastic waste, where you can produce hydrogen from one truck of plastic waste. You get 1 ton of hydrogen plus heat and electricity. Another example, pyrolysis also. You get some synthetic oil, like naphtha, which could be used for fuel production, hydrocarbon fuels, then some other material for the new polymer production. Okay, I think I spent my time.
Thank you very much. Mario?
So my small contribution will be on pyrolysis. So I have a couple of 3 slides or 4. Before I start, I'd like to tell you that when you forced me to be here, I told you that I don't know much about plastics, but actually we did something at IST on pyrolysis, not of plastics, and I just want to show you that, because actually it's not that difficult to do pyrolysis under lab conditions. So, yeah. So this is some images from something that we did there. A student of mine, MSc student. So as you can see, he has, sorry about that. What he did, we set up a very small apparatus in which we fed biomass, in that case. Actually, we did some mixtures of several raw materials, which probably is a good idea for plastics, for non-recycled plastics. And after we got, I mean, there's a zoom up of that there, and at the end we got char, as you can see, that residue that came out there, and that is the liquid that we got out. But in order to do that, and that is the point that I want to make, we had to heat up the biomass up to 500 degrees C, more or less. So we needed to consume energy. And actually doing a small balance, the energy that we are putting in was much less than what we are getting out. So this is an important issue, and now, in any case, if you go to the literature, the experts are talking about, this takes a bit, I think, but it will go there, no? Yeah. So, in order to here I'm talking only about non-recycled plastics, of course, which actually represents a large fraction of the plastics that, the waste material that we have. And of course they can, as Daniel said, they are a huge environmental problem, and possible solutions according with this nice paper from your journal. The plastics, we can have all these chemical valorizations from steam gasification, air gasification, pyrolysis and reforming, which actually is a nice thing to do these days. I don't know if about with plastics, and some more processes, and at the end, pyrolysis. So talking a little bit about pyrolysis, I got those two images from the literature. So basically pyrolysis, as you can see there, you can, those apparently are the recycled plastics, and they represent a very small fraction of what we have regarding the waste plastics. So those non-recycled plastics, we can feed them to a pyrolysis system in which they are lack of oxygen, of course, and you can end up with this kind of products. Tar, liquid, of course, those we can further refining them or upgrading them, let's say, but it's more money that we have put into the system, and at the end we can get some oil out, and gas, of course. Now, if you do core pyrolysis, as I was mentioning, which seems to me that is a better solution, or can be a better solution, in which you mix plastics or those kind of non-recycled plastics with biomass and even other kinds of residues. And in that case, the process itself is better, because one of the problems when we are doing this kind of experiments is the characteristics of the feeding material is changing quite a lot. And this is bad news for a system such as this one. And so if you are combining the plastics with other material like biomass, you can somehow be more flexible regarding the feeding of the material. So in that case, we have these two possibilities. I believe that this one may have, is promising at least, but I have listed here what I feel are the main drawbacks regarding the valorization of the plastics through pyrolysis. And those are high external energy demand. I have a picture just after this slide, which will be my last slide, in which I show that. There is, of course, a high capital cost, and I just mentioned that the inconsistent product quality. Of course, you can look at pyrolysis instead of trying to get fuel out of the system. You can look at the chemicals, which may be added value. But of course, for that, you have to have some consistency regarding those products. Anyway, it is difficult to establish one single route for all types of non-recycled plastics because we have different compositions. That is to say that, of course, we cannot select, we can probably, but it's difficult to select plastics with the same characteristics, and so this is another problem we have here. We have, and that I have experienced, my students have experienced at IST, we have to have optimal conditions which vary actually with the composition of the material that you are feeding to avoid problems like release of dioxins, pollutants even to soil and water. And there is a need, I have mentioned that already, to purify this bio-oil in order to make it usable, and this, of course, is quite costly. Now, in any case, if we can solve these drawbacks, and of course those are difficult to solve, the pyrolysis of these non-recycled plastics would result in a higher reduction of NOx emissions as compared with incineration process that Daniel mentioned. In any case, I'm not talking here about landfill, because I think it's out of question. Now, there is some, I managed to find this process in China, in which they give some numbers there. I cannot see it very well, but maybe you can. So, as you can see, they need, I mean, the numbers are there. They are using non-recycled plastics in this city. So this is a kind of new technology that they developed not long ago. Those are the plastics that, this is a heat balance actually, heat mass balance. So those are the plastics going in. This is the fuel going out, so is that fuel that bio-oil, let us say. There are other streams, including residues, or char residues, but look at the external fuel that they have to use, that amount, in addition to the gas that comes from the pyrolysis, they are using those also to feed the system from energetic point of view. So, just to conclude, I think co-pyrolysis of plastics with biomass, for instance, can be probably a good solution, or at least a way to try to solve the problem, due to the it seems that it provides, or it may improve the process performance, pyrolysis I mean, and also the process flexibility. I would like to draw your attention also for other promising alternative that now they are talking, which is pyrolysis combined with reforming in order to obtain hydrogen, and from there onwards you can go to ammonia, for instance, and other kind of chemicals that you can use even as fuels. So that is my small contribution.
Thank you very much. Who would like to come next? Yeah, Professor Iffy.
Yeah.
No, sorry. Okay, thank you. Okay, which one do you have?
Okay, may I ask Dr. Dubrovich to come? And meanwhile, we will sort out the technology.
Okay, thank you. Thank you for this opportunity. I will talk here about the plastics from the point of sustainability. So that's why this question is put on the front. Do we look for a solution? That means that we might have a problem with plastics. I mean, I wouldn't like to, it's not really my idea to question the usage of plastics. I think it's not possible to actually to imagine today's life without the plastics. Maybe we can talk about decreasing amount of plastics just easily used every day, but to erase it as a material with extraordinary properties, I think it's not feasible, and that's not the way to find the solution. So where is the problem? I mean, plastics, when released to the environment, due to the properties, we will never find or see any natural remediation. As we can see whenever we put some biodegradable like municipal wastewater, etc., we will, of course, it takes some time and space, but nature will take care about it. What happens with plastics? We only have fragmentation and accumulation. And that's the reason why we can observe the plastics all over in the nature, especially in the aquatic nature around us. So let's see a little bit the numbers Professor Schneider already gave us. I think today we reached almost 400 million tons of production in the world of plastic materials. It goes up. That's a 60 million in EU. And what is important that part of that material, a very important part, is released to the environment. We can count about 1.5 to 4% according to the very good reference that is released to the oceans. That is about 5 to 13 million tons of plastics each year to the oceans. So here are the sources of plastics in the environment: improper waste management, but also I want to stress the other two sources. This is tear and wear during the life cycle. We'll see what that is. And we also have intentionally added microplastics. So let's see the numbers. Around, for the Europe this time, 26 almost million tons a year, and just something like 30% of that is being recycled, and landfilling 31% decreasing, this recycling is increasing, and incineration 39% increasing. According to the estimates, 95% of the value of plastic packaging material, and that is in EU, 70 to 105 billion euros annual, is lost to the economy after a very short cycle of use. This is single use. What about the emissions? Due to the production and incineration of plastics, waste give rise globally to approximately 400 million tons of CO2 a year. So we see really a chance. Recycling of plastic can contribute to more effective use of resources, but also to reduce CO2 emissions. I mentioned tear and wear microplastics which are released to the environment during the life cycle. Most of it is automotive tires. When you buy a new tire, it has some weight. After 4 years, or I don't know how much kilometers, you can weigh it, and the difference is where? All across the streets and highways. So there are a lot of materials released each year in the environment. But also we have another group that is intentionally added microplastics, but designed for the product to be released after usage. For example, abrasive in toothpaste. Traditionally that was carbonate, a calcite, some form, and that was, of course, used in several minutes and just released to the drain, and in environment the calcite has its place. Could be deposited as a sediment and nothing special happens. What about the plastics? Plastics is an abrasive in toothpaste. Do we know the answer? No. We really do not know the answer. I'm wondering whether the industry is putting any questions about that. So there are a lot of materials and products with intentionally added microplastics for some purpose. There are many different types of properties which are gained by this simple addition of polymers into the materials, into the products which are sold every year in the world. We are using it, actually, many of us, and myself too. We are not aware of the fact that by using some products, we are really releasing effectively microplastics to the environment. That's also a part of the problem. So what is the risk? And if we talk about the risk assessment about these issues, I think we have many question marks. And our knowledge and our understanding of this issue is very limited. And actually it's, the iceberg and the top, which we can see when it's floating in the ocean, is maybe a good comparison. So we need to move. Actually, I can mention the result. I don't know if anyone here present in this room is familiar with the project, the Fish Gear, which actually finished these months. Very good, so maybe you can contribute in discussion. And if you look to the sea outside, a couple of times today I just kept my sight to the sea. It's wonderful, very nice, blue, looks so clean. But according to the study, in Adriatic Sea, you can find something about 100 to 800 particles of microplastics per each square kilometer of the sea. That much. Okay, for sure it depends on the weather conditions, and now with this northern wind, everything was gone to the south. But we really have a problem, and we just need to put some glasses, okay? So the scientists, researchers have to work on that. And actually, we need to find out the magnitude of the problem. And then to see how serious the problem is. And then to be more serious and more decisive when talking about this strategy, because European strategy, we can criticize it. I'm not coming from the European Commission, okay? But I think this is a good start, because to improve the economics and quality of plastic recycling, I think it's a very good thing. We know where are the problems, and we might find a way how to solve these problems to increase the rate of recycling. Curb plastic waste and littering. Yes, it's light, easy to get rid of, and these plastic bags and cups and everything is just released into the environment, and you know, it's not out of sight, out of mind, it's not my problem, but it's never-ending story for the environment, this even small piece of plastic material. Drive investments and innovation towards circular solutions. Yes, it sounds maybe too political, but it might have something as a real useful content. And harness global action, because European countries contributed to maybe 2 to 3% of the global problem. So I heard some, I'm coming from Croatian parliament, and I'm from academia, but temporarily I'm in parliament. And I heard some colleagues, they said, come on, it's not worth doing anything, because who is going to change the Africa and Asia and other countries, third countries? But this is really not responsible to say. And after all, industry. I mean, business and industry, their main criteria and task is to earn money, and that's absolutely okay. Money is running business and economy. But I guess that they should also take glasses with a wider view on these issues, because we are going to do a lot of problems without even knowing they exist. So if we want to be responsible for our kids and their kids, I'm not just political saying, but really we can do something. And this, what I found, that there is a funding of Alliance to end plastic waste, and they started spending, I think, $1.5 billion fund for solutions all over the world to solve problems and remove plastics from the environment. That is a good sign. Maybe we might create atmosphere, because understanding the problem, gaining responsibility, and asking all others and ourselves too to be ready for really active role, because the solution is on all levels, not only politicians, not only industry, but citizens, employees, employers, and so on. Okay, this is enough for my introduction. Thank you.
Thank you very much. Yeah, I really appreciate it, because you've got very good numbers, and some numbers are really horrifying when we see it. Okay, Professor Iffy, can we manage?
Yeah, I had my children doing some work today on the beach. So I had been collecting the glass on the beach.
Oh.
Yeah. So that's the glass from the beach today.
This problem. It's
okay. I was late because I was swimming with my children, and I gave them some work as well to do today, because you know you have your little helpers, and my children are my little helpers. So what I got them to do is to collect the glass. So it's not alone plastic that's in the environment, it's glass as well. And people forget that, okay? And all different types of glass in terms of colours. My children think it's beautiful, they collect it, they love, and they argue about who is the different coloured glass. But when they see the plastic on the beach, because we collect that too in my hometown when we go to the beach, they don't like collecting the plastic. And recently we were on the beach and we go swimming and we do surfing. We like surfing. And we went in surfing and we came out and the group of eco-cleaners on the beach had taken my daughter's flip-flops to throw them in the trash, in the rubbish, to take them away, to put them in the bin, because they thought they were rubbish. But I saw the 2 flip-flops and I said, why did you think? Oh, we thought somebody forgot them. But would you not recycle them, I said. So here they were making a point, collecting plastic, but yet they had thrown the useful flip-flops in the bin. So when I was young, and I was a child, we had a thing called a milk float. Okay? Now, if anybody's from the UK or Ireland, they probably remember these things. They were electric vehicles. They were wonderful. And they came around at around maybe 5, half 5, 6 o'clock in the morning with bottles of milk in glass bottles with an aluminium seal top. And the milk was lovely and fresh and it had cream on the top. If anybody remembers when you had milk from a bottle, it had cream on top. Now, milk from plastic doesn't have the cream on top. I don't know what it is. That's a question that I always have not answered. So the issue really is, it's a bit of a battle between glass and plastic at the moment. And everybody's argued, or, well, they haven't argued, they've had a friendly, put forward a different ideas. And this is the purpose of what we are doing here in the panel, is for ye to think about this. So, is it clear glass? You know, I look at the waste there, it's clearly not glass. But of course, you know, you could live on an island and you can still have the glass. But of course, then plastics are made of oil. And oil is made of dinosaurs, and plastic dinosaurs are made from real dinosaurs. I hope you don't realise that, if that's an interesting fact. And Jerzy pointed out that Ireland is actually one of the biggest producers of plastic. And remember I said today, you know, you should question. And people are shocked when they see this. That's because we're one of the largest pharmaceutical exporters in the world. And we produce a lot of products such as toothpastes and shower gels and tablets, okay? And we also produce a lot of power electronic goods and electronic goods. For example, 15,000 people work for Apple in my city. And Otterbox also makes products and works in my city. So even though Ford and Dunlop left, they were old industries and they went to cheaper locations, it was replaced 10 years later with new companies. So the problem is these things can become quite confusing. And we're trying to figure out, what do we recycle? And that's the big question. So what glass is worth recycling? Is it worth recycling glass in certain countries? Is it worth recycling certain types of plastics? How do we separate and segregate these? And I told you that I worked in industry for 12 years. And when I worked for one particular company called SDEWES, I said we developed wind farms and CHP plant. One of the projects I also worked on was with a company from Rotterdam in the Netherlands. Okay? And they were one of the largest incinerating companies across the EU, and what they do was they'd ship in a lot of waste into Rotterdam and they'd burn it in the incinerators. Okay? So what also happened was they'd collect this plastic from across the EU, Ireland included, and at the time it was 2011, it was 2007. And part of the problem, which one of our colleagues highlighted, is what's recycling? So is it pyrolysis? I think it was Costas. He said, what sort of levels of recycling do we need to go to? So for the purpose of this recycling, it was basically shaking it in a bag and then putting in a container and shipping it to China to be incinerated there. Okay? And then they were paid to do this recycling. So China took 95% of Ireland's plastic waste. And we realised this is a problem. Yeah? So we can recycle. But if you look in the bag there or in that box, it's bottles, cans and aluminium. Glass bottles, plastic bottles and aluminium cans. So the issue here is now, how do we separate this waste and all these waste streams? to make them into valuable products and commodities again. So this is all a matter of regulation and governance, and sometimes politicians, because we have so many governments and such a fast turnover of politicians, more recently, we have an issue with governance and regulation because politicians are so busy arguing about things. In my case, it's Brexit, and we can't get rid of the government, okay? The problem is that then we come to an impasse in terms of regulation and what we do. So for me, somebody asked me today, what's your message? And I'm Irish and I give you many messages, okay? There's no one solution. It's not a case of glass versus plastics. It's a complex life cycle analysis problem. More recently, people have been using the term circular economy. We have to close the loop of production in terms of recycled raw material production. So we talk about manufacturing 4.0. But it's all really hinges on our stewardship and people's behaviour. But another issue more recently is composite materials. And one of the first composite materials, and it made a family very, very wealthy, is Tetrapack. It's a plastic-coated cardboard. And I cried when I got rid of it. I remember them bringing in, because you see, when you had the glass bottles, you could leave them outside the classroom when I was small, and it would keep the glass by its mass would keep the milk cold. But the plastic bottle or the plastic Tetra Pak with the little straw didn't keep it cold for long anymore, and it wasn't as tasty. So the amount of milk that was being consumed by primary school children in Ireland steeply declined. So the problem for us is we have in the renewable energy sector, we have composite blades in wind turbines, we have composite materials in PV panels. So when we moved from glass to plastic, we never did a proper life cycle analysis. We never looked at the issues. We didn't think about it properly. So this is another thing that we're going to experience now in the renewable energy sector. We have to close that loop, okay? So the issues here are our knee-jerk reactions. Do we jump on a bandwagon when we see a whale washed up in a beach and they cut open its stomach? But as Jerry Yurtzi pointed out, it was pointed out in 1970-odd. It's been known about for a long, long time. So it's about human behaviour. It's our attitude. How are we going to deal with these things? It's about industry, the environment, energy and equity, the 3 E's of the Brundtland Report. And I want to bring everybody back to that again. It's about the end of life, but it's also about new products. So how can we make new products out of what we have? So the virtual footprints are also very important, and that's because I showed you China. So where's the plastic going now? I tell you where it's going. It's going to Africa and it's going to India. Okay, so that's where this is going now. So it's also about regulation and governance. So the thing about it is, it's society, it's our choice, it's our vote, it's our voice, and it's our problem. And I just wanted to show you something very interesting here. It took nearly, I think, 78 years for 50 million people to get on a plane. It took 19 days for 50 million people to join Pornhub. So that tells you about people and the psyche. So some people, it's like Yurtzi as well, they'll either love us, they'll hate us, or they'll be indifferent to us. They'll be indifferent to us because we're saying something that they know but they don't want to hear. They'll hate us because they don't want to talk about the problem. They love us because we'll talk about the problem and we'll inspire them. So the thing about us having the panel in this community today is to inspire younger people and older people alike to try and influence a change in terms of what we're doing, the governance and regulation of all these issues. Okay, thank you very much.
Thank you very much. And the last contributor is Dr. Ma from Xi'an, Jiaotong.
Good evening, ladies and gentlemen. Actually, I haven't conducted any research on the waste plastics. So I will try my best to introduce what I found in my literature review. Just now, many people mentioned that the China played an important role in the waste plastic disposal. Yes, it's true, because many new policies have been proposed by the Chinese government. So my topic is the technologies and the challenges of converting waste plastic to fuels. At the beginning, I would like to give a brief introduction of the waste plastic status in China. Maybe you know that China just celebrated its 70th anniversary of its founding 3 days ago. It showed the great achievements of China in the past 70 years. But in the meantime, the rapid economic development brought many environmental problems. Here shows the waste in the Hong Kong, Suzhou, and Hebei province. The annual output of the municipal solid waste in China is about 400 million tons, with the annual growth rate greater than 8%. So much waste brought many environmental problems, such as the very famous fog weather, and also brought the threat to the human health. Therefore, in recent years, the Chinese government highly values the ecological and environmental protection, guided by the conviction that lucid waters and large mountains are invaluable assets. The country advocates the harmonious coexistence between the human and nature and sticks to paths of green and sustainable development. This is also one of the most important objects of the Chinese dream. An important measure in this year is the waste classification, which is launched by the Chinese government. Take the municipal solid waste as an example. The municipal solid waste is extremely non-homogeneous due to the climate, culture, living standards, and dietary habits. So it is important to do the waste classification for the waste disposal. In China, the applicants industry, business domain, and agriculture industry provide more than 60% of the total source of the waste plastics. The amount of supply of waste plastic keeps a rapid increment greater than 10%, which reached 31.63 million tons in 2018. The demand and investment of the waste plastic industry are increasing rapidly, and it also has very high profit, more than 23% in average. Because the waste plastic is difficult to decompose, the lead filling and incineration are the most common treatments in China right now. However, these two methods lead to serious environmental pollution or resource waste, so the recycling is a better choice. With the development of the economy, ecological, environmental, and sustainable development continues, the waste plastic recycling has received more attention in China. As you see in this table, the recovery rate is greater than 20%. There are many technologies used for waste plastic recycling, including the incineration power generation, recycled plastic particles, and plastic to fuel conversion. Among these technologies, the plastic to fuel conversion is a promising technology. So in the following 2 parts, I will give a brief introduction about 2 important technologies to convert the plastic to the fuels. That is the thermal pyrolysis and the catalytic cracking. The thermal pyrolysis is a process of thermally degrading the long-chain polymer molecules into the smaller, less complex molecules through the heat and pressure. The thermal pyrolysis of the polymers follows either the chain end degradation as shown in the equations 1 and 2, or the random degradation routes as shown in the equation 3. It has been chosen by many researchers since the process is able to produce high amount of liquid oils up to 8% at the moderate temperature around 500 degrees C. The thermal pyrolysis of waste plastic grocery bags at temperatures of 420 to 440 degrees C provides 74% yield of plastic crude oil. This oil can be used for various applications, such as the steel factory, boiling, heating, heavy oil generation, or the cement factory. The thermal pyrolysis of the waste plastic is simple and mature, so it has been widely used in North America, Europe, USA, Japan, India, and also in China. But it needs high reacting temperature to get lighter hydrocarbons. The hydrocarbons between the boiling points of 35 between the 35 and 185 degrees C, it can be used for motor gasoline. Between 185 to 290 degrees C, it can be used for diesel number 1. Between 290 to 350 degrees C, it can be used for diesel number 2. And between 350 to 538 degrees C can be used for vacuum gas oil. The component and the yields of the products are determined by the thermal treatment temperature, plastic type, residence time, and reactor type. The temperature controls the pyrolysis reacting of the polymers. So the temperature is considered to be one of the most important factors affect the quality and quantity of the pyrolysis products. However, the major drawback is also the temperature, because it requires high temperature, and there is a very broad product range. The thermal pyrolysis can produce large amount of liquid oil for different plastic types. The residence time is a temperature-dependent factor that has much influence on the product components, especially at a low temperature. Most thermal pyrolysis process in the lab scale were performed in the batch reactor, fixed bed reactor, fluidized bed reactor, and conical spouted bed reactor. The reactor type has an important impact in the mixing of the plastics, residence time, heat transfer efficiency, and of the reaction towards achieving the final desired product. The catalytic cracking is an ionic process involving carbonyls ions and are produced by addition of a proton from an acid catalyst to an olefin and abstraction of hydride ion from a hydrocarbon by the acid catalyst or by another carbonium ion. The fluid catalytic cracking is one of the most important conversion process used for petroleum refinery. It is widely used to convert the high boiling, high molecular weight hydrocarbon fraction of petroleum crude oil into more valuable gasoline, olefinic gases, and other products. The waste plastic was originally recycled by the previously just mentioned thermal pyrolysis, but the catalytic cracking shows greater potential because it produces more gasoline with a higher octane rating, produce byproduct gases that have more carbon double bands and hence more economic value than those produced by the thermal pyrolysis. The catalytic cracking on the acid catalyst takes place in the formation of the carbon that required the strong acid sites. The acid strength and its properties, such as the BT surface area, acidity, pore size, pore volume, thermal stability, and the dimensions are the main characteristics of the acid catalysts. The catalyst type and quantity have different effects on the pyrolysis process and its products. The waste plastic have high viscosity and low temperature, so the heat and mass transfer is an important factor, and a suitable reactor is very important. Take the fluidized bed pyrolysis plant as an example. The process heat is introduced indirectly into the bed through radiant heat tubes, in which the pyrolysis gas is incinerated. The exhaust gas are used to preheat the fluidizing gas by means of heat exchanger. We can see that the heat transfer is very important in the catalytic cracking. Now comes to a summary. At first, it found that there are huge needs and markets of waste plastic recycling in China. The waste classification and related environmental policies bring great opportunity for the waste plastic recycling. The thermal pyrolysis is a simple and mature technology for the waste plastic recycling, but it needs high temperature and produces more liquid fuels. The thermal treatment temperature, plastic type, residence time, and reactor type have significant effects on the thermal pyrolysis. The catalytic cracking shows great potential, but it is not mature. Because its advantage is that it only needs lower operating temperature and produce more high-quality gas fuels. The catalyst and the reactor type have great effect on the catalytic cracking. It is necessary to develop cheap and reduced catalysts. At last, I would like to express my sincere appreciation to Professor Qiwang Wang and my two master students, Mr. Zirui Xu, Ms. Na Li, Mr. Jie Lian, and Mr. Zhenling Wu to help me with this presentation. That's all. Thank you for your attention.
Thank you very much. It has been a really interesting and comprehensive way how to deal with waste and what is the situation in China. And at the end, I will ask Ms. Yiwan Fan for a few slides to conclude the opening contributions, and we can start to discuss. We still got some time.
Good evening. In the introductions by Professor Clemach, he highlighted the importance of assessing the footprint of different alternatives for the plastic. And now I would like to give a brief introduction on the accounting and the challenges, the footprint accounting and challenges. So start by looking at the EU statistic. By looking at the EU statistic, we can see that 39% of the plastic waste is incinerated, 31% ended in the landfill, 20% is recycled. This makes up 100%. But how about the plastic leakage and marine litter, which is the most important issues of plastic waste? And also, when we look at the US statistic, it shows the same. The plastic leakage is not captured. And also, we can see that the recycling rate in the US is decreasing. This is because of the developing countries stop receiving the waste, exported waste. And also, most of the time, we are assuming that the exported waste and the separated recyclable waste is recycled. But this is not necessarily the case. To capture the plastic leakage, one of the research team proposed the plastic footprints, which consider the macroplastic as well as the microplastic. The plastic footprint quantifications is important so that it can integrate with the other footprints for comparisons, such as the GHG footprint, energy footprint, and water footprints. But there is a challenges. The first challenges is the data availability, and the most important one is the understanding of the fate of macro and microplastic is still yet to be identified. Like what is the degradations when ended in the oceans, and what is the impact to the ecosystems. This slide shows some of the existing and under development plastic footprint methodology and tool. The table is not too visible, but if you are interested, you can refer to the cited source. And what I would like to highlight in this slide is that all of this methodology and tool did not include the environmental impact of plastic leakage, which means it is not suitable for comparisons among different alternatives. So this is the main research gap in comparing different alternatives, which we need more understanding on the fate of the macro and microplastic when ended in the oceans or leaked to the environment. Together with Professor Clemach, we prepared 2 questions to initiate the discussions. The first one is, are ban and reduction a sustainable solutions? This is quite a complex question because it associates with the environment, economic, and also the social impact. And also the plastic are just too efficient to be easily replaced. Instead of viewing the plastic as an enemy, we can focus on control the marine litter. This is the main issue as shown by Professor Clemach. Paper cup is having more GHG emissions than the plastic. So we can focus on the control marine litter and also focus on redesign and recycling. But of course, there are some challenges, which is the mixed plastic, pigment, additive, and contaminants, which make it difficult to recycle. The second question is regulate the manufacturer or consumer. A month ago, I attended a global plastic waste symposium in the US, and this is one of the questions that asked by the researcher, which is also a lawyer. She's saying that most of the time we are focusing on the consumer. We are blaming them on buying the plastic products. We are asking them to do the separation and recycling. But is that the responsibility of consumer? This is some of her arguments, The first one is separating and collecting is not equal to recycling. They are doing their job, but the waste sometimes is ended in the landfill, even it is separated. And the second argument is that the consumer is purchasing according to the given choice by the manufacturer. Manufacturers know well about the material compositions, but the consumer have a limited information on that. So whether it is recyclable or not is still a question. For example, the paper cups. Because of the thin plastic layer, it is not recyclable. And also, by regulate the producer to manage the product at the end of its life, it can actually encourage redesign. The manufacturer will find a way to use the recycled material and also to improve the easiness for recycling. So these are the two potential questions for discussions, and I will pass it back to Professor Flemish.
Thank you very much, and I am asking our panelists to come on the podium, and we've got a little bit more than half an hour for the discussion. Before we start, let me shortly summarize what I learned from the presentations. It's been very interesting to hear different opinions from different angles, and probably the problem has got, as always, the number of steps. And it starts like all waste from the first step is avoidance. If we can avoid using too much plastics and too many plastics, it would solve a lot of problems. It is not easy because, as I said, I attended conferences where everybody at the beginning received cup with the conference logo and said, please keep it and use it for your coffee, for your tea, and for your water. It's a small example. There are some other options which Daniel mentioned. You know, it's about using different ways of sorting. And I think it has got a good potential, robotic sorting, with potentially some smart plastics. If we can add to each plastic something what can be easily recognized by a robotic machine, it would help. But there are some small things, because we've got categories on plastic, 1, 2, 3, 4, 5. But they are not easily visible for customers. You know, if I'm coming to a recycling box, I would prefer to have it 1, 2, 3, 4, 5, and on my piece of plastic, it is somewhere on the bottom, you know, to find it. Okay, we are as consumers usually a little bit lazy. If I would get this one such a big, I would put it to the right place. Now, how to deal with the waste? For me, it's very valuable information that in China, the business is profitable. And I think it's a great news. I'm not sure how it is in the EU. If somebody from you has got the information, I suspect that it might be in the EU subsidized. But if it's profitable, it's great. Another issue is very much about the management. The management can solve a lot of problems. You know, to find the new ways how to use it, how to move it around supply chains, and so on. Of course, we had some interesting ways how to deal with the waste. And this is natural, and I believe that we are mainly engineers. This will be developed more and more. What I haven't heard any opinion is about replacing waste. this is this issue if we should totally say waste is bad, plastic is bad and we have to go to paper or something else. I've shown the slide showing that from the point of environmental footprints, not all those replacements are really environmentally friendly. So this is another issue. And also been mentioned the issue about micro-waste. And micro-waste, who knows, how big is it a problem? You know, we haven't got the figures from medical authorities. Is it a big danger for human beings, or it's something what, you know, because a human being is very flexible. Otherwise, we as the group wouldn't survive, because we lived in very different conditions and adopted many things, but we don't know. And again, if it's really dangerous, something should be done. At the moment, we haven't got a legislation, we haven't got anything. Okay, I was talking too long. So now it is on the audience and on the panelists, everybody is welcome. Yes, please.
Hello, everyone. My name is Robert Bedovic. I come from University of Zagreb, and I have a question for the panel. So what do you think, what will be the position or what will be the role of bioplastics in the future plastics management issues? Thank you very much.
Okay. Yep.
Bioplastics? Yeah. Sorry, did he say biomass or bioplastics? Bioplastics. Yeah, but bioplastics are like microplastics. We really don't know. We actually really don't know.
For example, PLA, polylactic acid. You can produce it using aerobic process, but in the end, it's compostable.
It is,
but
it
not
is like,
degradable.
Yeah, no, I agree with you. It is
issue.
compostable, but it has a huge opportunity. But the problem, and if you notice the last slide, they highlighted that, you know, the issue is it's a product. So it's a product design issue. So if you talk to some people who early started to bring use bioplastics, okay, and biodegradable plastics, what you'll find is consumers complained. And then, yes, sure. and this was one of the key issues, and this is one of the challenges of bioplastics. So it doesn't give you the same performance characteristics. So you're wondering, how does she know these things? Okay.
I have a colleague in Ireland.
Because I actually read a lot.
Yeah, I have a colleague in Ireland who is on PhD and he works on this, on this issue. So I know
plastics is a big thing for us because it boils down to tablets, and we make lots of tablets. Okay, so that's one of the things why we're interested in bioplastics. Next.
I can also add to some comment. I will talk about the current situation, about the sorting and collection and recycling. If you start, but considering bioplastic, the problem with bioplastic, if you have, for example, bottles, and now they are collected in the same system, you will have huge problems in recycling. That is current problem, of course. Maybe smart factories, automatic sorting could solve that, but currently it would be quite bad for the current system. Okay, that does not justify not using it.
They're looking at laser techniques, part of the recycling process.
Okay.
I'm Hrvoje Stanjin from University of Zagreb. I have a question for Professor Costa. You were showing the co-pyrolysis and stated that external heating may be needed. Do you know maybe, or can you estimate the number, which percentage can be saved by this external heating when the byproducts of pyrolysis are utilized for this process? So Do you maybe know some rough numbers? I know it's hard to say precisely, but some rough numbers and percentages.
How much represents the gas that we, not more than 10%. Because it's a low calorific value gas, you see. So it's just, it's quite small.
Okay. Yeah, we've got 1, 2.
Okay, shall I ask? Okay. I just wondered for some of the plastic packaging that is used, it's actually not necessary to use them as much as I can imagine. Like the deposit system, for example, exists in yogurts or milks still. One can use the glass packaging for the milks and the yogurts and return them to the market. There are maybe, can you hear it?
Sorry, no. Sorry, we are not able to understand you.
Really? Okay, I can hear myself very well. I wonder why. Because now I'm in from the loudspeakers. So I was telling that for the, is it better now? Yeah. Okay. For most of the packaging, plastic packaging that is used, like for the yogurts or milk, or even the cosmetic products, I guess it's better now, yeah. Even the cosmetic products like toothpaste and shampoos, deodorants especially, there are some, I mean, one can use glass packaging, and one can even use the deposit system for these systems, for this product as well. And do you know why plastic usage is not banned for packaging of these products, for example? I can imagine that it is not possible, maybe for pharmaceuticals, it's not that easy maybe in terms of conserving them longer, but for these kind of products, it's not necessary at all to use plastic. Maybe if you could explain a little bit why these things are not banned already. Thank you.
Okay, I can try to give you on the deposit one. Yes. So you're right. The deposit refund systems, if you mention them, they are working now in like 40 countries and regions in the world. I don't know if any of you have it in your countries. It's as a beverage container deposit, you know, the fee, which is returned when you return the bottle. In Croatia, we have it on glass, metal, and PET. And you mentioned, coincidentally, you mentioned milk and dairy products. From the start, I think, of the next year, and currently this is in the legislation, we are putting back also in the deposit the dairy products, yogurt, milk, etc. None of other systems has it because of there are some hygiene and safety issues, you know. But we had it till 2015, and now they are putting it back. According to some other products, I'm not sure. I mean, there are some initiatives to put other products like fishing gears. I think you mentioned one of the European initiative. So they think to put the deposit of fishing nets also. And about the other plastics containers, I'm not sure that this is currently possible. And you have to be aware that these systems are quite costly if they are not managed efficiently.
I'm sorry, when you say it is costly, there is no way to return the damage that we are making. I think cost should not be an excuse. Does that make sense? I don't know.
Can I have a comment on this? Because I think that the question was more on why we don't ban the plastic material and replace it with the glass or something like in the packaging. I would say that I don't see plastic as a problem for packaging, but what we must promote is reusable plastic packaging. That's no problem to have a container and refill it with the shampoo or something. And that is something that should be promoted because glass it may be a good solution, but I mean, not always. It's breakable easily and so on. I don't know That was your question, or?
I mean, even you say that the plastic is some of them is reusable, like the deposited plastic. They can be recycled only for a certain number of types. So this is not like glass that you use. One can also argue then that, for example, in the restaurants, I can bring for my sauce my pack with me. You know, it can be a metal thing. Then I can wash it and use it a lifelong. And the same, for example, for the napkins. People used to use just a piece of cloth, and just everybody buys napkins now. So I think plastic production is just easy for the industry. That's how I feel about it. And people are also lazy, and when it is not enforced on us, we just go the way that it used to be. And I think these kind of things should really be banned at some point.
Sorry.
Okay, fine.
Can I
answer, please.
I keep on saying all the time, and I've said it, I've been coming here since 2009. I think the first time I came to this conference was in 2009. And I talk about the social aspects of what we do as engineers, okay? So I'm an engineer, and engineering is applied science, it's practical science. And I've said all the time is that basically it's up to us to inform people. So I give you an example. And I'm going to show you why there's an issue with product and packaging and why we can't sort of overnight decide we're going to ban. You as a consumer will go into the shop, and if the lady in the shop or the guy who's serving you in the shop brings you down a shirt where the package is damaged, do you know what happens to that shirt? It's sent back, okay, and it's sold as seconds or thrown out to the landfill. Because the company like Nike, okay, or Gucci won't want to have a problem with the consumer. So when a child goes and buys their Lego, yeah, and I have Lego blocks in my house that are 40 years old, if the box is broken or torn, when they buy it as a present for the child, and this is cardboard, they won't buy it. So it's not really, you know, it is an issue of there are definitely too much packaging coming with products. But it's up to us to tell the companies that are selling us these goods. It's like the straw that Jerry showed us from McDonald's. I've tried to drink a milkshake through one of those straws, and I tell you, it's a challenge, okay? And actually, I hate drinking out of a straw. I just open the plastic lid. I don't even want the plastic lid. So it's up to us and our behaviour, but it's up to us to tell these politicians, okay? Because if we don't tell them, what will happen is they're going to make some sort of assumptions, okay? And no disrespect to anybody who's a politician, okay? Sometimes they're not the brightest bunch, okay? So that's all I want to say on packaging. But it's up to us to tell the companies and to tell our politicians that we want certain things changed.
Okay, thank you. You know, I think we should be very careful not to adopt some conclusions which are not really based on deep analysis. And this is the problem of media, because if you look in the media, plastics are evil. And we should remove them everywhere. Well, I'm old enough to remember the world before plastics. And it wasn't very good. You know, each polymer, a new polymer, being a huge leap ahead. Can you just imagine that you would, in this room, remove all plastics? Well, all mobile phones and many things would disappear. About packaging. Packaging with plastics is very helpful, and it helps many things. But again, it's the matter of management, because market economy, you know, if you go to the supermarket, there are increasing amount of plastics for packaging. You know, if you've got, say, butter, and butter packed in paper, it's not too attractive. It has to be full of colors, different shining, and so on. When you mentioned those microplastics, it is again, it can be made without it. but toothpaste wouldn't be 3 colors, wouldn't be reflecting. What you put on your face to look marvelous, it's again full of microplastics. Would we want just to dump it? Probably not. We should make a proper deep analysis based on environmental impact for everything what we are going to replace, and not to make it too hastily. Anyway, Hrvoje was next one.
Peter was before, but Peter was before me, but I can, okay, I can do the question. Hrvoje Mikulčić, University of Zagreb.
Put it closer to your mouth, please.
Okay, Hrvoje Mikulčić, University of Zagreb. I hope you can hear me now. Okay, I have a real life question. So, I'm teaching my kids to do the waste separation, so they know how to do the biodegradable plastics, glass, everything. But there are certain products, for instance, it may be silly, but diapers. It's a huge problem. What to do with them? It may be silly, but it really is a big problem.
Okay.
The Chinese do. You don't
Yeah.
have to have your child in a diaper all the time.
Yeah.
I don't have that problem anymore.
Well, I tell you why. When I worked in industry, it was a major problem in the waste company that we were dealing with, that we had bought over when I was in SDEWES. Okay? And what was happening was people were actually throwing diapers and their take-out food cartons into their recyclable materials. Okay? You know, in the wastewater treatment plants and systems, do you know what they find? Car blocks, battery blocks, engine blocks, because people do really stupid things. So, if you go to China, you'll see kids, when they're potty training them, they get to a certain age, they just leave it all hang out. You're going down the street and you'll see this child standing there and they'll have their arse out into the air. Yeah, they don't need to have a nappy on all the time. What's wrong with some poor kid having a dump on the street? You know, it's learning how to do something. It's normal, it's natural. Now you know, it's like two extremes. We either all wrap up, but we're against the hijab. We either all wear nappies or we've no nappies. Okay, so there's no answer to the question. Okay?
At least thank you for that.
Thank you. Yes, please.
Maybe you can use reusable diapers.
Yeah.
Washable.
We were trying with that.
That was another problem.
Okay, we've got some more. Yes.
Thank you. I would like to respond to the milk and yogurt issue with glass containers. This looks like a great idea, of course, but there are some hygienic issues, like we have already mentioned, so we have to be very careful. Because I know when I was younger, we had glass containers, and it circulated all around for maybe months for other users. And then they finally put it back and get the deposit. So even they put chemicals in it, everything. You don't know what has been inside that before it has been redeposited. First of all, maybe you should put a small date on it so that you have to return it back in 2 days, something like this. Otherwise, to be able to make it really hygienic and sterilized, it becomes too energy intensive and water intensive. And sometimes this might override the issues with the plastic. So although this is a good idea, it's a more sterilized, more hygienic medium, we have to be quite careful and make a balance between the heat and water dominance that is used for cleaning. And also, usually they get chips on their mouths, and these chips harbor bacteria, etc., and it's also difficult to clean them. So we have to be careful. Thank you very much.
Other than those mentioned problem with glass, There's another problem is that glass is more heavy than the plastic, and you need to be careful of the footprint shifting because during the transportations, it will release quite a lot of GHG emissions. So we also need to consider that in the assessments.
Okay, thank you. Petar?
Okay, I would like to a little bit reinforce what you said about identification of the impact on the humans. It's part of identifying the whole problem of plastics. There have been studies, because I made the literature study, there have been already studies which identified damage to ecosystems. And so definitely identifying the damage on human body, if there is any, should be done. But we should also look, this is the severity of the problem, but we should look also at the extent of the problem. And as we both know, microplastics have been found in many places. So I think this is another challenge, how to identify a map of this microplastic pollution.
Okay. Anybody wants? Fine. Another comment? Mohammed, yes?
Okay, thank you very much. My name is Mohammed from Brno University of Technology, Czech Republic. My background is business, so I have an angle from business side. If we back to about 10,000 years ago, until 100 years ago, people live and they don't face to mostly this kind of problems that we have. Mostly this problem, it happened since 100 years ago. And as Professor Ifi said in the morning, her grandmother has 14 children and her mom, I think, 7. So they didn't have any problem with diapers for their children.
Washing all the time.
Yes, exactly. And yeah, and this happened mostly is because of about 100 years ago, it's become mass production and the companies can make and produce more products. The other thing was about marketing. Because of marketing change, they can change the mindset of the people. They make need for them, they use the need that they need, and they sell the product and make as much they can make money and profit. So when we see this trend and this happening, many of the problems that currently we are facing to, it happen like this. It's about plastic, it's about many other things. And the reason is because we change our mindset and our lifestyle. Okay, so what we should do now for these problems that happen? We have in re-engineering and we see what's happened and how was it. We learn from the lessons and we try to solve. I don't say we need to back and live like 100 years ago, but we can solve the problem. When I was studying industrial engineering for my bachelor, I learned something about fishbone. In fishbone, we put the problems in the like fish stone bone, and then we categorize them, and then there is a hypothesis for Pareto. It says that 20% of a problem has 80% of the value, 80% has only 20%. So when we categorize like this, we see plastic is used in what part of the world and what part of our need. We can try to reduce and replace and see for 100 years ago how people and with what material they use. For example, for the spoon, before in my area in Middle East, they use clay to produce it. It is natural. And also it's very easy for environment to absorb it. Maybe for other part they use wood for having this. And because we become more greedy and we want more and more, in the name of health, in the name of hygiene, in the name of other things, they put this plastic into our life as much as they can because they want to make money. So if we want to really solve this problem, we need to attack like this. 80% of the problem has only 20% of the value, 20% only has 80. Thank you very much.
Okay, thank you. Anybody wants to make comment?
There's a gentleman down there, sorry. Yeah, you gave a very interesting presentation on greenwashing.
Okay.
Okay, my name is Martin Hayek, University of Pardubice, Czech Republic. I have only some small comment about the packing, because the packing may be some small problem in degrading the plastic would be packing more effectively. Because if you buy something, it is a big box, inside of small box, and inside is maybe some small box, therefore in the end is waste of maybe half what you buy. Maybe waste is something happened that waste is more than you think. Therefore, if the packing was more effectively, smaller, bigger, it should be maybe solve some problem in degrading the plastic material. Thank you.
Okay, thank you.
Sorry, there was a very interesting presentation I attended yesterday. It was on Sustainable Development Goals in Economics. I think, was it you, George? He's sitting there now quietly. He's from Portugal. He's the blue shirt on there in front of the lady with the red. He's you chaired the session, did you? Oh. Like, I mean, people think I walk around and I don't listen. Okay. I never switch off. But he was chairing the session.
And it will be the last one, because we have to complete.
And it's just, I want him to tell about the greenwashing. This thing they use, it's very important and it relates to everything, and it's about consumerism and products, yeah? And it's about the toothpaste and everything we're talking about, and that girl and the nappies. We have to be very careful of companies, because things can be badged to look whatever way you want them. Appearances can be deceiving. It's like an electric vehicle. It's not a zero-emission car. Yeah? So just people be careful. That's all I wanted to say. It's called greenwashing.
Okay, Hervoje, the last word.
Okay, just quickly then. I believe that no one mentioned that there was a ban on single-use plastic products, which is a major good progress made for the plastic. I didn't hear a comment on that, and do you think there will be more of this consumer products that will be banned in future?
Ban on single-use plastics, I think that is the part of the solution, because we are exposed to the pressure of the market. When I go to the market store in Zagreb and buy some vegetables, they need to give me 3 plastic bags in order to be strong enough to hold something. So that is out of mind. So someone has to stop it. So why not to use a solid, thick plastic bag and reuse it each time? So I think that the ban is part of the solution, not the single one. So, and working on the, we are talking about recycling and the problems of recycling. It comes together with separate collection, sorting lines, and development of green economy. Someone has to turn these collected polymers which must be free of food and other things that contaminate them, and convert it, regranulate it, wash it, separate in different polymers, and bring it back to the economy. That's quite feasible. But if we look at the bins all around, let's say in Croatia, there are a total mess about that. It's very, very badly organized, and everyone is arguing it's not functioning. I mean, we must look at the place where it is functioning, so and put the things in right order. Someone talked about feasibility and the cost. Yes, we don't know actual cost of this plastic in the oceans and the seas. Do we know that? No, we have to discover it. How much is gonna cost us? Because according to the study, I read that 3 out of 10 fishes contain some microplastics in the digestive system, and that some of these plastics it is already found that pass through the membrane and found it in the blood system of the fish. So we need to discover what are the externalities. Nobody accounts that. But if we want to talk about economics of the system, we must take in account these externalities, which are very hard to estimate.
Okay, thank you. Perfect timing. We are just going to conclude. I think we can take it as a conclusion. Thank you, everybody from the panel. As Mario said, sometimes I had a little bit persuade, but thank you very much, because this is the issue I think we shouldn't finish just with this evening. It's the issue which will return and return more and more. And thank you everybody who stayed with us to this, well, it's still social time, but otherwise, others are already enjoying the food and drinks, and you actively contributed. Most appreciated. Thank you.